Our next topic in talking about statements is going to be about quantifiers, and in particular, quantified statements. First, we're going to define what quantified statements are. Then we're going to define what it means to be a domain of discourse of a quantified statement. We're going to focus on two types of quantified statements. One is existential, the other is universal, and they are statements whose syntax begins with either there exists or for all. We're going to figure out when quantified statements are true and when they're false. And finally, we're going to figure out how to find useful negations of quantified statements. So in order to figure out what a quantified statement is, the most straightforward definition is it is a statement that answers the question how many or maybe how much, depending on what kind of quantities that you're looking at. So for instance, if I want to ask how many real number solutions does the equation 2x plus 3 equals 9 have, the answer might be the quantified statement, there is exactly one real number solution to the equation 2x plus 3 equals 9. If I ask the question how many people are asleep right now, well, maybe I don't have to give an exact number or an exact quantity for that. I could say something like, there are at least 100 people who are asleep right now. It is still a correct answer to that question. How many of the natural numbers are prime? A single number isn't going to do it because there are so many prime numbers. We have to say something like, there are infinitely many natural numbers that are prime. And I should say at this point that we made quantified statements based on correct answers to the question that gave us true statements. But if we want to answer the question incorrectly, that also is an appropriate quantified statement. It just happens to be a false one. So if I say, for instance, there are exactly 5 real number solutions to the equation 2x plus 3 equals 9, that is incorrect. Still a statement, just happens to be a false statement. Okay, so now I want to talk about the domain of discourse, which shows up implicitly in every single quantified statement that you can have. Because when we're talking about how many, we're not just asking how many in a very abstract and ambiguous way. We want to say how many of what. And to show you what I mean by that, let's look at the quantified statement we had saying there is exactly one real number solution to the equation 2x plus 3 equals 9. How many solutions? How many solutions of what? Right? We're not talking about solutions being matrices or being Boolean values. We're talking about them being real numbers. So our domain of discourse in this case, we're talking about real numbers. So we need to make sure we're clear about that in our quantified statements. Or if we say there are at least 100 people who are asleep right now, yeah, the 100 is important. That's the answer to our question. But we have to make it clear we're talking here about people. And when I say there are infinitely many natural numbers that are prime, we're talking about natural numbers. So we need to make clear what we're talking about. Generally, that is what our domain of discourse is. So the domain of discourse of a quantified statement is the set of objects that are being considered in the statement. And there is an analog of this in coding, something that you usually have to deal with. Actually, sometimes not so much in Python, but certainly in things like Java. When you define a variable, a lot of times you have to say what type of variable it is, and the type could be a domain of discourse. So if you decide that this variable is going to be an integer, integer is your domain of discourse. If you're deciding it's going to be a Boolean value, the set of Boolean values, that's your domain of discourse. So we're going to concentrate on just two types of quantifiers. One's called existential quantifiers, and one's called universal quantifiers. So let's say you have a domain of discourse D. So that's just a set of all the things that we're considering in our quantified statements. And we're going to let P of X be some statement about X and D. And so what I mean by that is you can take any value of X and D, plug it into P of X, and it will give you a statement. So P of X actually may represent many, many different statements, one for each value of X. An existential statement looks like the following. There exists some X in our domain of discourse such that P of X is true. And I want to talk a little bit about when that's true and when it's false. It's true if the statements P of x is true for at least one value of x and d. So in other words, if you plug in all the possible values of x and d into P of x, if at least one of them comes out to be true, then your existential statement is true. And that means it's false precisely when P of x is false for every value of x and d. If you plug in all the values of x and d into P of x and get false every single time, our existential statement will be false. Universal is kind of similar in syntax, except instead of there exists, it's for all. So for all x in our domain of discourse, P of x is true. That's a universal statement. That is going to be true if P of x is true for every single value of x in our domain of discourse. In other words, if you take all the values of x and d, plug them into P of x, and you get true every single time, that'll make your universal quantified statement true. And that means it's going to be false if P of x is false for at least one value of x and d. If you plug in all the values and get at least one false, that's going to make your universal statement false. All right, so let's look at some examples. So if we want an existential statement, we actually had one in our set of examples before. There exists an integer x such that 3x plus 4 equals 5. So in this case, our domain of discourse, what are we talking about? Well, we're talking about integers, so our domain of discourse is the set of integers. Our P of x is 3x plus 4 equals 5. Note that that is a sentence. 3x plus 4 is our subject, equals is our verb, 5 is our object. And even though 3x plus 4 isn't a statement by itself, our domain of discourse is the set of integers, and if we plug in any integer into that equation, it will become a statement. And in order to figure out whether our existential statement is going to be true or not, we're going to solve for x, and 3x plus 4 equals 5. If we do that, we get x equals 1/3, which is definitely not an integer, which means there aren't any integers that make that equation true. So if we plug in all the integers into 3x plus 4 equals 5, we are always going to get a false statement. So every integer value makes P of x false, which means our statement is false. For our universal statement, we have for all real numbers x squared is greater than or equal to 0. So in this case, we're talking about real numbers, so our domain of discourse is the set of real numbers. Our P of x in this case is x squared is greater than or equal to 0. If I plug in any real number in for x, x squared greater than or equal to 0 is either going to be true or false. And it turns out, actually, it's never going to be false. If we square any real number, multiply any real number by itself, we'll never get a negative number, which means it's always going to be non-negative, which means that our P of x is true for every single real number x, and that means our statement is true. All right, so now let's take a little bit of time to talk about negations of quantified statements, and in particular, useful negations. So if I have an existential statement like there exists an integer x such that 3x plus 4 equals 5, and if I want to find a negation of it, the thing to remember is finding the negation of a statement is describing exactly what it means to be false. So I'm going to review what it means for this statement to be true and what it means to be false. So true means that 3x plus 4 is equal to 5 is true for at least one integer x. So there's at least one integer x we can plug into that equation to make it true, which means that in order for it to be false, it needs to be true that 3x plus 4 equals 5 is false for every single integer x, because if it's not false for every single integer x, that means it's true for at least one, which makes the statement true. Now, if you look at the language in that description of what it means to be false, notice that it has that for every in there. And that tells us that the negation is going to be a for all statement. If I want to describe what it means for that statement to be false, I need to describe it as a for all statement, as a universal quantified statement. So the negation is going to be, well, let me see, it's for every integer x, and I've got to be able to say that 3x plus 4 equals 5 is false. So the way I can say that as a universally quantified statement, for all integers x, 3x plus 4 is not equal to 5. So let's see what happens when we try to negate a universal statement. Well, the example that we had is for all real numbers x squared is greater than or equal to 0. Let's again think about what it means for it to be true and what it means for it to be false. True means that x squared is greater than or equal to 0 is true for every single real number x, which means that false means that x squared greater than or equal to 0 is false for at least one real number x. And once again, we have some interesting language in what it means to be false, that for at least one. For at least one, that is exactly what we mean by there exists. So the negation is going to be an existential quantified statement. So we're going to have for at least one real number x, so there exists a real number x, and then we're going to have to say that x squared is greater than or equal to 0 is false. And well, let's see, how's that going to work? Well, there exists a real number x, that's what we mean by for at least one real number x. But if we want to say that x squared greater than or equal to 0 is false, the way to say that is x squared is less than 0. So there exists a real number x such that x squared is less than 0. Alright, so now that I've given you a heads up of how to deal with quantified statements, there is a PDF file called Quantified Statements that is included with this video.